In the second part of section 6.5, we're going to be looking at the side-angle-side similarity theorem. Now keep in mind with similarity, we know that angles are congruent, sides are proportional. And that's the case with side-angle-side. We need an angle to be congruent and the sides around it to be proportional or in the same ratio. So if we have two triangles, and if an angle of one triangle is congruent to an angle in another triangle, which you see here, and the sides including these angles are proportional, then the triangles are similar. Remember, with included angle, it's the angle between the sides we're looking at. So if the sides including these angles were proportional, in this case, I would need sides x, y, and yz to be proportional to mn and np because those are the angles, the sides around this angle. So I would need this to be true. I would need side xy in comparison to side mn to be in the same ratio or proportion as sides yz compared to np. Again, reason why is because these are the two sides around or including that angle. So we need the angle to be congruent, we need the sides around it to be proportional or in the same ratio. I'll just kind of highlight these sides. And then we can use side-angle-side similarity theorem. So to use this in an example, I'm using the enlargement of triangle XYW, so this must be triangle XYW here, to triangle JHK, and you notice I'm enlarging it kind of by using a vanishing point type thing. Are these triangles similar? Well, I notice right away I do have an angle or a degree marked here, so these angles are 80 degrees. I now have a congruent angle, and you notice I am given the lengths of the sides around that angle. Potentially, this could be side-angle-side similarity, but I would need these sides to be in the same ratio. So I'm testing, is 16 compared to 24 going to be the same ratio as 18 to 27? And I can reduce both of these ratios, but I want to bring up another way to test whether these are the same. I could write 16 over 24 equals, and I'm comparing 18 over 27, and then just put a question mark because I don't know this yet. But one of the easiest ways to test whether a proportion is true is cross multiply and see if you get the same things. So I can do 16 times 27, and I get 432, and then I can do 24 times 18, and I'm hoping for that same thing. And yes, I get 432. So yes, these sides are proportional. I got the same cross product. So yeah, the triangles are similar by side-angle-side similarity. Because I had a congruent angle here, and the sides around it were proportional, they are similar triangles by side-angle-side similarity. If I had reduced 16 over 24, I would have gotten, let's see, I'd be dividing by what? 4? And gotten, oh, I'm sorry, I could divide by 8. 16 divided by 8 is 2, 24 divided by 8 is 3, and I could have reduced 18 over 27 dividing by 9 and gotten 2 over 3 as well. So either way that you're going to do that, you can see the sides are proportional, angle between them is congruent, side-angle-side similarity says the triangles are similar. And let's summarize a little bit here. We now have three methods or three sort of shortcuts for showing that triangles are similar. And hopefully remember these three methods that we have. Triangles are similar by angle-angle similarity. You would need these two angles to be congruent. Remember that angles are congruent in similar figures. We have side-side-side similarity. We talked about that yesterday. We would need all the sides to be proportional. Sides to be proportional. So they all reduce to the same ratio. And now today we have side-angle-side similarity. The angle is congruent and the sides around it, or including it, are proportional. So three shortcuts that we could potentially use to show that triangles are similar. Remember that two angles congruent actually means all three angles are congruent. So any of these is enough info to show triangles are similar. And the reason I'm summarizing these is because some of your examples today asks you to tell what method could be used to show the triangles are similar. So the first one, I'm looking at two triangles, and I notice what I'm given is all of the side lengths. The only possible method that could work here is side, side, side. Similarity, because there are no angles. So I'm hoping the sides are all in the same ratio. To check that, remember that you should compare like shortest side to shortest side, longest to longest, etc. So if I look at the shortest side here, it would be 16. I'm going to compare that to the shortest side here of 12. Reduce that by dividing by 4, and I get 4 to 3. Then compare longest sides. Longest side here is 32. Longest side here is 24. Divide by 8, and I get 4 to 3 again. And finally, middle length side here would be 20. Middle length side here, 15. Divide by 5. And again, I get 4 over 3. So the sides are proportional. So side, side, side similarity would work here. The sides are proportional, therefore the triangles are similar. Alright, what about in this example? We're not going to be able to use side, side, side because I'm not given these side lengths. I'm given two side lengths, which means I have to be given an angle that's congruent, and you notice what types of angles do we have here. We have vertical angles, so I know those are congruent. Now I am given the sides around the vertical angles, so if I can show those are proportional, potentially it would be a side angle side situation. Let's see. Are the sides around it proportional? I know I'd compare 8 to 20 because 8 was the shorter of the two sides here and 20 is the shorter of the two sides there. That reduces, divide by 4 and get 2 to 5. And I would compare 12 to 30, the longer of each side in these triangles, divide both of these by 6 and get 2 to 5. And yeah, once again, these are equal. Now these triangles would be similar by side angle side similarity. We had an angle congruent that was in between two sides that were proportional. So side angle side similarity works here. Oh, interesting. Okay, in this picture, it looks like we have two right triangles here, and technically we have a third triangle, which would be the largest triangle here. I think maybe I'll start by looking at the two smaller triangles. Now, instead of checking all three side lengths, I could potentially maybe use side angle side because these are congruent right angles. So I'm going to test the sides around the right angles, which in this triangle is 9 and 12, this triangle is 12 and 16. Now the shorter side of this triangle would be 9. So I would compare to the shorter leg here of 12. And I'm going to do the does this equal. So I compare the shorter side of this triangle to the shorter side of this triangle. Longer leg of the triangle on the right is 12. Longer leg of this triangle is 16. To check whether these equal, I cross multiply. Now I know 12 times 12 is 144. Is 9 times 16 the same thing? Yes, I get 144 either way. So these triangles I can say are similar by side angle side similarity. But let's say I'm going to look at the big triangle now, which has sides of, well, this side would be 16 plus 9, or 25. So sides of 15, 20, and 25. Alright, let's maybe look at the little triangle. Big triangle to the smallest triangle. Let's see if these are similar. The very little triangle has the shortest side of 9. The shortest side of the biggest triangle, 15. 9 to 15 divides by 3, and I get 3 to 5. Okay, let's do the longest side of, the little triangle first. Longest side was 15. Compare that to the longest side here of 25, divide by 5, and we get 3 to 5 again. And finally, the middle length side of this one was 12. Compare that to the middle length side of that triangle, the big triangle, which is 20. Divide by 4. And once again, we get 3 to 5. So big triangle, little triangle, those are similar because I tested all three sides. They're similar by side, side, side similarity. And okay, so first I did the two smaller triangles. Then I did the big triangle, the little triangle. And finally, without even testing, why is the big triangle similar to the medium triangle? Well, if I have these two similar, and this guy's also similar to the big guy, why is the medium one similar to the large? Well, it's sort of that transitive property idea. I know we haven't talked about transitive with similarity, but it would be the same idea. If you have two things similar to the same thing, then they're similar to each other. So it's kind of neat. We actually had three similar triangles in this picture. So today, looking specifically at side-angle side similarity, where we have to have an angle congruent and the sides around it proportional, but looking at all of the similarity shortcuts we have for triangles, which includes angle-angle similarity. If you have two angles congruent, well, technically all three angles are congruent then, and the triangles are similar. And side-side-side similarity as well, which says if three sides are proportional, then triangles are similar.